Wow, welcome once again to Chemistry Meal, a lovely and nice program designed for all students to help students in studying chemistry effectively and efficiently. Subscribe to our YouTube channel at Mathematics Meal 1 and also follow us on Facebook at Mathematics and Science Meal. Also follow Engineer Ike Okechukwu on Facebook. Now today on Chemistry Meal, we are going to look at part 2 of electrochemistry. And in this part 2, our business is on the concept of what? Oxidation number. Let's begin this wonderful journey on oxidation number. Let's do it together. All right, so let's begin. So first, we must know what we mean by oxidation number. What do we mean by oxidation number? So, we say that oxidation number or state, so if we don't want to call it oxidation number, we call it oxidation state, is the charge assigned to an element in its ionic state. So the charge an element will carry when that element becomes an ion, that's what we call oxidation state. There are other definitions of oxidation state or oxidation number. You can also say that the oxidation state, oxidation number, is the number that shows the number of electrons gained or lost by an atom of an element in order to combine with other elements. You can also say that it is the charge that determines the extent or the degree of what? Oxidation or reduction in a given element. Yes, the charge that determines the extent of oxidation or what? Or reduction in a given element. So that charge, we know that charges are formed when there is either gain or loss of what? Electron. That's when we form ions. So whenever we form an ion, there will be a charge that will be on an atom of an element. And that particular charge will give us the oxidation state or the oxidation number of that element. Okay. So now oxidation number is very, very important. This is going to be just a very brief video. Oxidation number is very important, very important. That's why we are taking our time to look at the concept of oxidation, starting from the first part of electrochemistry. So by our definition, if I write this, let me write sodium atom, and I have sodium ion. If I have calcium atom, and I have calcium ion. If I have chlorine atom, and I have chloride ion. So you look at all this. If I have sulfur, and I have sulfide. Okay, now this is sodium atom. Now this is sodium ion. This particular charge that is now present in sodium ion, that's the oxidation number. So the charge an element we carry or an element we have when that element is in ionic state is what? Is the oxidation number. The charge that will be assigned to an element when that element is in ionic form is the oxidation state. Now this charge can only be formed by gain or loss of electron. For example, this positive charge is showing us that one electron was lost. These two positive charges, they are showing us that two electrons have been lost. Now this one negative charge is a sign that this chlorine atom gained one electron. So the negative charges are in excess in this particular ion by one, because you know that an atom, a neutral atom, that's what we call it. An atom is electrically neutral because it has equal number of protons and equal number of electrons. In other words, equal number of positive charges and equal number of negative charges. That's for atom. But once we have an ion, because they are formed by gaining or losing electron, there will be imbalance in the number of protons and the number of electron. That's the number of positive charges and the number of negative charges. So that's what we mean by oxidation number or state. So when you hear oxidation number, it's still the same thing as oxidation oxidation state. Just take note of that. Okay. Now, I'm going to talk about two main uses of oxidation number. The knowledge of oxidation number, the knowledge of oxidation number, oxidation state. So the knowledge of oxidation number is used in the following areas. What are those areas? Area number one, in IUPAC nomenclature of inorganic compounds. So we use it in IUPAC nomenclature, and we also use it in balancing equations, especially the ionic equations, balancing equations. So the knowledge of oxidation number is necessary in the nomenclature, that's in naming what? Naming inorganic compounds. For example, you have this and you have this. Now this one is carbon 4 oxide, this one is carbon 2 oxide. Why carbon 4 and carbon 2? The oxidation state of carbon here is 4. That's the origin of that 4. Then this place, the oxidation state is what? Is 2. That's why this is carbon 2 oxide. If you go to nitrogen, you have this, you have this, you have this. All these are oxides of nitrogen. So it will be clumsy calling them nitrogen oxide, nitrogen oxide, nitrogen oxide. So when you say nitrogen oxide, how do we know the one you are talking about? So from oxidation number, this is nitrogen 2 oxide. This is dinitrogen 1 oxide. This is nitrogen 4 oxide. That means the oxidation state of nitrogen here is 4. The oxidation state of nitrogen here is +1. The oxidation state of nitrogen here is what? Is there is +2, yes. That's nitrogen 2 oxide. Nitrogen 1 oxide, that's dinitrogen 1 oxide, and nitrogen 4 oxide. So oxidation state of nitrogen here +4, +1, +2. That's why it is nitrogen 2 oxide. The same way, if you go to this compound now that contain nitrogen, this one, you see this? Sodium dioxo nitrate what? So if you don't know the oxidation state, you cannot name this. Sodium trioxo nitrate what? So this is sodium dioxo nitrate 3. The oxidation state of nitrogen here is 3. That's why it is sodium dioxo nitrate 3. So you see, it will be practically impossible for you to carry out nomenclature of inorganic compound if you don't know what? If you don't know oxidation state. This one is sodium trioxo nitrate 5. The 5 there is because the oxidation state of nitrogen is what? Is 5. So one of the vital uses of oxidation number is in what? IUPAC nomenclature of inorganic compounds. Remember, inorganic, not organic compounds. Because when we come to organic compounds, we have nomenclature for the homologous series that you encounter. Okay. Then the second one is balancing equations. When we come to redox reaction, we are going to see the importance of what? Of oxidation number in balancing what? In balancing equation, especially the ionic equations. Yes, all redox reactions are mainly ionic. You can put them in ionic form. They are usually ionic. So we are going to see how we can use the knowledge of oxidation numbers of elements in balancing what? Equation. Because they are not like the equations you just balance only in terms of moles. You also balance those equations in terms of charges, and that's where the oxidation number plays important role. Thank you for watching our video till now. At least you know the meaning of oxidation number, and now also you know the two uses of oxidation number. In our next video, we are going to look at the rules that are guiding oxidation number. We're going to have about 7 to 8 rules that will help us in solving problems in oxidation number. Thank you and God bless you. I still remain your lovely tutor, Engineer I. Okechukwu. I love you.